Welcome to my talk, Simplifying kubevirt, New Tools for Easier VM Management. My name is Felix Matouschek. I'm a senior software engineer at Red Hat, working on kubevirt, including its command line tooling and its Ansible bindings, and also on other parts more related to the core of kubevirt. So let's have a look at today's agenda. So first, I wanted to give you an introduction to kubevirt. Then we'll have a look at the latest enhancements of kubevirt's CLI. Then I will show you how you can automate the VM lifecycle with Ansible. And then I wanted to show you a demo of both these topics. And lastly, I wanted to show you some next steps for that. So yeah, what is kubevirt? Kubevirt is a way to run and manage VMs on Kubernetes. So kubevirt might be an opportunity for companies that already have VMs, running VMs, and that want to get to know Kubernetes. So all you can do with traditional VMs, you can do with kubevirt VMs as well. But kubevirt brings VMs into the container world, so now you can do container stuff with them as well. So you can use all of the goodies that Kubernetes provides. So for example, services or the storage, etc., on Kubernetes. All of this stuff you can now use with VMs as well. And so Kubernetes has to offer something on top of traditional VMs. And also, it allows you to combine virtualized and containerized workloads, which means they now can work together on the same cluster, for example, over the same network, talk over the network to each other. And for example, this allows the use case of developing new microservices that talk with already existing, possibly legacy applications that have been run virtualized. And yeah, for all of this, kubevirt extends Kubernetes with several VM-related custom resource definitions, CRDs. Because CRDs are not enough to run actual VMs, the logic required to run them is provided by additional agents and controllers. And under the hood, kubevirt is using libvirt and QEMU to run one QEMU process per container. And here at the bottom of the slide, I put a link to our homepage and also to our user guide. So if you wanted to learn more about kubevirt, please check it out. So next, I wanted to show you a basic virtual machine definition in kubevirt. Only very briefly, you don't have to pay like super close attention to all of the details here, but in the next slides, I will show you some like excerpts of machine definition, and just so you know what we're roughly talking about. But if you wanted to get like the full experience, there's a link to the API reference here at the bottom, and there you can check out all of the possible options. Lastly, I wanted to give you a quick reminder about a topic I've given a talk about in the past already, which is instance types and preferences. And those will become a bit more important later in this talk again. And so what are instance types and preferences? Those are custom resource definitions combining the runtime sizing and resource sizing and runtime preference settings of a virtual machine. Those can be referenced by a virtual machine, one of each, and those will be used to apply those settings to an actual running virtual machine, which is called virtual machine instance, and that is derived from a virtual machine object. And so preferences, in a bit more detail, what are those? So runtime preferences are things that your guest OS would expect from the virtualized hardware. So for example, let's say we have a certain amount of vCPUs, and then we need some way to specify how we want those to be represented in the virtualized hardware. So in this case, you could choose to spread your cores across sockets, or your vCPUs across cores or across sockets. That would be a preference, and those are very specific to OSs. And at this point, kubevirt ships predefined instance types and preferences. So we support the most common OSs like Ubuntu, RHEL, Fedora, etc., all out of the box. And one more nice thing about instance types and preferences is that they enable an image-centric workflow. So if you already have an image of your guest, all that's required to boot it is an appropriate instance type and preference, and you can label your images with those, and then that's enough to get started to get a running VM. And keep in mind, this is just a different way of defining those settings. the full YAML definitions, like the thing I showed you before, that's still viable, still usable. So if you need the full customizability, you can still choose to do so. Yeah, so finally, let's have a look at kubevirt CLI, which is called virtctl. So that is a tool that allows you to control the lifecycle of virtual machines. You can start, stop, restart them. You can also create VMs with it, also instance types and preferences. And for that, the tool provides a fixed set of CLI flags, which allow you to adjust the parameters of the objects to be created. So, for example, in case of a virtual machine, you can set its name, you can set its boot volume, or the instance type and the preference the VM should use. And then this tool outputs manifests, and those could be piped into kubevirt.core or OC, so that allows you to directly create objects on a cluster. But you could also choose to save them into a file, then you can customize them further, and then you could deploy them with kubevirt, or you could choose to use another approach. So, for example, GitHub's approach, you could check those manifests into your Git repository, etc. And also, virtctl provides some more quality of life features. The most important one would be the remote access to SSH, SCP, and VNC. So for that, all you need is access to your cluster's control plane, which typically you would have that if you run Kubernetes. And that's enough to connect to those services, and essentially port forwarding is used to make those services available. Now to the enhancements to virtctl in the 1.4 and 1.5 development cycle of kubevirt. Virtctl create VM gained several new features. So the first one would be the generation of basic cloud init configurations. Before that, you could already pass your own cloud init configurations to it, but they had to be base64 encoded and needed to be passed on the command line to a flag, which not very user-friendly, but hey, I guess it worked. We also now support the injection or the dynamic injection of credentials. For that, we're using the Access Credentials API of kubevirt. And also, we now have support for sysprep volumes. That means Windows guests are a bit better supported now by virtctl create VM. Also, many more cleanups and fixes were applied to virtctl, and the most important one would have been the unified volume import. So now we have a streamlined user experience when importing images from various sources, such as HTTP or the registry, or other possible supported sources we have. All right. Now let's have a closer look at the generation of basic cloud init configurations. Those let you log in and use your VMs right after creating it. So there's no more need to compose basic configurations yourself. And I have a basic, an example command here. So I'm running virtctl, I'm passing it the user flag because I want the user to be my user, and then I'm passing it the SSH key flag, and for that I'm reading in an SSH key from my home directory. And below is an excerpt of a virtual machine that was created, and we can see under its volumes that there was a cloud init configuration volume injected. So we have a cloud init disk, and in its user data you can see we have the actual cloud init configuration. And so it looks rather simple, but in my opinion, it makes life amazingly easy because, especially in dev environments where you need to create a lot of VMs and throw them away again, it's a real time saver. And yeah, at the bottom of the slide, there's a link to our user guide, which shows you in a bit more detail how you can actually use virtctl to create VMs. Next slide is injection of credentials, this time dynamically. So before that, with Cloud Init, credentials would have been injected statically, and then they would have been part of the actual virtual machine definition. And with this feature, we can now dynamically inject public keys or passwords from a secret. So again, I have a command here for virtctl create VM. Again, the user flag, and this time I'm passing it the access cred flag. This flag takes a lot of parameters, but in this case, I'm only passing it the source parameter, which tells it to source the credentials from a secret, which is called my keys. And below, there's again an excerpt of a virtual machine, and we can see under its access credentials that an SSH public key was added. And by default, the access credentials API is using the guest agent inside the virtual machine to inject those keys. So what we see here, we have the propagation method QMO guest agent, and we have our user, and we're telling it to source the keys from a secret called myKeys. Yeah, what's awesome about this is that we now can separate our virtual machine definition and our credentials. So in my opinion, that's best practice. We don't need to store any sensitive credentials in the virtual machine. Instead, we can store them in a secret. That was virtctl, which works well at a small to medium scale. And now I wanted to show you how you can manage VMs at a larger scale. And for that, I want to show you how you can automate the VM lifecycle with Ansible. Ansible is a ubiquitous tool to automate IT tasks. I'm sure you've heard of it. And kubevirt now provides its own Ansible collection, which is called kubevirt.core. And this collection, it provides lean bindings that support the most common tasks with kubevirt VMs. And it also allows you to reuse existing tooling and approaches. So all your existing playbooks and rules, you can now all use them with virtual machines on kubevirt, because the collection makes them available to Ansible as any other type of VM that is supported by Ansible. And also this now allows you to manage day 2 activities at scale. So let's say you have a fleet of VMs on kubevirt and you want to upgrade their software packages or install a new software package. You can now do with regular playbooks in Ansible. And at the bottom of the slide, I put a link to the repository of the collection. So if you encounter any issue with it, or if you have any suggestions or wanted to have a look at the code, please visit it. Also, you can get this collection today from Ansible Galaxy, and it's also included in the default Ansible distribution. So if you install Ansible, I think starting version 9, and we should be at version 12 soon, you get this out of the box with Ansible. So let's have a closer look at what's inside this collection. So we have some modules. First one would be the kubevirt VM module. This module allows you to create, update, or delete virtual machines. It's kept lean intentionally, but it still supports changing most parameters you could find on a virtual machine. And for that, it essentially allows you to modify the spec, which would be used to create an actual running virtual machine. Also, it allows you to wait for changes to be propagated. It might sound obvious, but if you start or stop a VM, this is a task which could take a little bit longer, and so by default it's asynchronous. But if you have following tasks which depend on your previous task, so for example, starting a VM, this module allows you to wait for that. So you can continue with your next task once the VM is started. Also, we have the kubevirt VM and VMI info modules, and those allow you to look up VMs on a cluster. You can look them up by also by namespace or by label selector or field selector filters. And it allows you to also gather information about a specific VM. So for example, you wanted to have a look at the status of a specific VM, you can do so with these modules. And also, they are read-only, so they cannot harm your VM, you cannot harm your workloads inside that VM. It's safe to run them against your live workloads. And lastly, that's my favorite part of the collection, which is the kubevirt inventory plugin. This lets you populate your Ansible inventory dynamically. So for that, it fetches and updates inventory data from a live cluster. And that's like the key feature which allows Ansible to interact with kubevirt VMs. So it tries to discover the SSH connectivity to a VM automatically. Under the hood, that means it tries to find a suitable Ansible host and Ansible port combination. There's a certain precedence to that. So you could choose to configure a specific network on the virtual machine by name. If not, then it will try to look up services. It supports node port and load balancer services. So if a service could be found, it will use those to set the Ansible host, the Ansible port. And if not, then it will fall back to the first interface on a virtual machine, which typically is the pod network. So if you run Ansible and your VM in the same cluster, in the same pod network, then you could still access your VM without any extra configuration. And yeah, this plugin is designed to handle large-scale environments. So you can group and filter by cluster name, namespaces, labels. It supports all of the features you would typically find in an Ansible inventory plugin. So you can use caching, keyed groups, composed variables, all of the stuff you would expect from an inventory plugin. And also you can use it with AWX and the likes. Okay, now, quickly some enhancements in the latest version of the collection. So earlier I told you it can look up SSH services, and now we support also looking up of WinRM services, which means if you run a Windows guest instead, it will try to find a suitable Ansible host, Ansible port connection that exposes WinRM of a virtual machine running Windows. And also we were able to make some minor quality of life improvements. So first we had some issues around idempotency. So typically if you run a task which is not changing anything, you want the changed condition on the task to be false, not changed. And there were some issues around that, but we were able to resolve that. And also we now better support run strategies. So in KubeVirt we have two ways of running, managing the running state of a virtual machine. And run strategies uses the new way, and now the collection also supports to switch an existing VM, which was using the old way, to the new way to run strategies. All right, so enough of the talk. Time for a demo. I wanted this demo session to be focused on people already running Kubernetes, wanting to give KubeVirt a try. The aim of this demo is to show you a scenario that uses both the CLI and Ansible. And it will show you how you can get a running cluster and how you can connect Ansible to it. And I will try to do this live, so we'll see how lucky I will be or not. And if not, you could always go back to my slides, and I have all of the commands I'm going to run on the slides, so if you wanted to try it yourself, please do so. So we have first a quick summary of what we're going to do. So first I'm going to prepare an environment. Next I will be creating an instance type and a preference with virtctl. Then I want to create a VM with virtctl and Ansible. Then I want to populate my Ansible inventory dynamically. And lastly I want to run a regular playbook against this virtual machine to deploy an application. And we'll also reference some files in my commands, and I put those in a repository, and the link is down here at the bottom of the slide. So last slide. How do I prepare an environment? I did this already on my machine, but I will show you this quickly. So there's some certain prerequisites to it. First we need Ansible. Then we need Docker or Podman. We need kubectl, and we need virtualization support enabled on the host running this. So we're going to make use of the test setup with kubevirt.core, and thanks to Podman or Docker, we can easily get support for secondary networks, which means we will have layer 2 connectivity to our VM, like it's typically found in many real-world deployments, layer 2 or layer 3. So first, install kubevirt.core from Ansible Galaxy. You can run this command here. Next, install virtctl. I'm downloading it from the GitHub releases page. And lastly, I'm checking out the repository of the collection, and then I bring up a cluster by running make cluster up. So now let me switch to my console, and let's hope for the best. Okay. This is very small, but I hope it works. Yeah. So first thing, I wanted to create an instance type and a preference with virtctl. And for that, let's run those commands. So first, the instance type. We'll try, sorry. Better? Okay, so I want to create an instance type. Now it's broken again, that's great. yeah, I wanted to create an instance type with virtctl. I wanted to have 2 vCPUs and 2 gigabytes of memory, and I piped this directly into kubectl, so it's created on the actual cluster. I can show you what this would have done without piping it. This is the basic manifest, so yeah, very simple, but hope it gets the point across. Next, I wanted to create a preference. Again, I will pipe this into kubectl to create it in my cluster, and then I will show you the manifest. So as I told you earlier, the instance type specifies 2 vCPUs, but I want to spread those across cores. So I want my virtual machine to have 2 cores, and I can do this with the preference. So I created this preference here, which sets the CPU topology to cores. Now I'm going to create the virtual machine with virtctl. Okay. So, or I'm not creating it, but I'm preparing it. So this would have been the manifest of my virtual machine. I passed the command some flags. So I wanted to use Fedora container disk. We're going to run a Fedora guest. I wanted to use my instance type, my preference I just created. And I wanted to use an SSH key, which I have in this directory here. And this is the actual virtual machine definition that was created by virtctl. And I took this and enhanced it with a secondary network. So I talked about the secondary network support earlier. You still need to do this manually. And now I will run Ansible and create the actual machine on my cluster. So this is using the kubevirt VM module I told you earlier about. And now, yeah, let's hope for the best. In the meanwhile, this playbook, I should have shown you before, but it's pretty simple. Like, it's only the extra interface I just mentioned, and that's about it. It looks very similar. So now we have to wait. Okay, virtual machine was created on my cluster. Next, I want to populate my inventory dynamically. For that, I need an inventory configuration. I have this basic configuration here. You can see it a little bit better like this. So it's telling it to use the kubevirt plugin. I want it to look at only the default namespace, and I want my virtual machine to have a network which is called bridge network. And now we can run Ansible inventory to actually try to look up the VMs on the cluster. And it was successfully. So this is the machine that was found. Under its host vars, you can see the host is called default-test VM. That means host name is test VM and namespace is default. And we can see it was able to find an Ansible host. So this is the actual IP address on the secondary network of the virtual machine. And lastly, I want to deploy an application on this virtual machine. For that, I've prepared a very basic playbook. Except that. So I prepared a basic playbook. So this is simply installing HTTPD on the virtual machine. So this is running in the virtual machine now, and then it's starting HTTPD so we can access it. This is already using the inventory plugin, so it's now connecting over the dynamically discovered VM and running those commands via SSH. And I hope this works. That's the typical fun you get with live demos, so like to live dangerously, but it worked. Or we will see in a second. So actually, let's go into a browser and visit the IP address of the virtual machine. Yeah, and we can see it works. So I was able to deploy an application on the virtual machine. So let's go back to the slides. Yeah, it works. So yeah, I prepared this backup slide in case it wouldn't have not worked, but it worked. So yeah, what did we do? Let me quickly recap. So we successfully created a virtual machine, kubevirt, environment with secondary network support. We used virtctl to abstract our runtime preferences and our resource sizing into an instance type preference. We then used virtctl and Ansible to create a virtual machine. And lastly, we let Ansible discover this virtual machine dynamically, and then we applied a regular playbook to it. So yeah, that was my demo. I hope you liked it. And on my slide, all of the comments are contained. And if you wanted to try it yourself, please do so. If you encounter any issues, don't hesitate to contact me. I'm happy to help. All right, last slide. So some next steps. We still wanted to make virtctl a little easier to extend, so there's some refactorings required for that. And then we want to carefully add new features to the collection. So first would be the support of sub-resource APIs with kubevirt.core. I told you about run strategies, and those are best used in combination with sub-resource APIs, so you could start, stop, restart your VM. Then we want to support fact caching to better support large environments. This is also a little bit depending on Ansible still. And lastly, we need your feedback. We need to know from you what you would like to see in the collection. That's it for today. Thank you. And do you have any questions?
No. Questions?
Hi. This credentials insertion mechanism described in slide 10, does it support specifying like non-default namespace?
I think you have to be, the secret has to be in the same namespace as the virtual machine.
I'm sorry?
The secret has to be in the same namespace. That was the question,
Sure.
right?
Sure.
Yeah, it has to be.
Okay. And the second question, perhaps I'm just not familiar with the way how it works, but this inserted credential is then available as a environment variable in the virtual machine, or how is it become available from within the VM?
The guest agent, so it
Yes.
relies on support in the virtual machine, and
Yes.
the guest agent will write the authorized keys file of a user. So
Uh-huh.
I set a user here, and if you have if you have a secret with all the keys you want the user to have, it will inject those keys into the authorized keys file of a user.
Okay, thanks.
And also, if you have passwords, you can also specify the passwords for users from a secret. Thank you.
I got a question around the virtctl. Were there some ideas? Right now, the kubectl supports plugins. Were there some thoughts that that you would create a plugin to kubectl which would allow configuring the kubevirt itself?
Kubevirt itself.
So similarly as now you have a virtctl binary, you can create kubectl kubectl plugins which can extend.
You can actually use virtctl as kubectl virt. It's possible. You can, if you put it in the right directory on your home directory, I think. Yeah, if you put it in the right place, then it will support that. You could use it as extension to kubectl. But it will do essentially the same, like it's the same if you called it separately.
Yep, great, thanks.
I was just wanting to add something to that. Martin, I don't know if you're familiar with Crew, the package manager for kubectl. So there is the kubectl virt plugin already existing, so you can just install that if you want. Should be updated whenever there is a new kubectl or virt release. The virt package should be updated, should be working.
Yeah, but it's exactly the same binary if you put it run it separately. Yeah. Thanks.
No other questions? All right, so thank you.
Thank you.